Okay, we have a synthesis reaction here. It says this guy synthesized ammonia gas by combining hydrogen and nitrogen gases. So let's write down the reaction here. So we got hydrogen gas H2 plus nitrogen gas N2 will make what is it, ammonia gas, which is NH3. Well, before you do anything, you need to balance it. Let's balance here. We got two H's, three H's, so probably put three here and then put two here to make it six. And then which makes, yeah, it's balanced, 3:1:2 ratio. So A is done. B, let's see. We got 10 kg of nitrogen combines with excess hydrogen. So we know this is in excess, meaning this is a 10 kilogram of nitrogen. This is a limiting reactant. Okay. Let me move everything up a little bit. Let me see. Okay, so we're given that's in temperature, so we have to, that's in Celsius, so 550, that's pretty high. And then you have to change it to Kelvins. I'm just going to use 273. Okay, if your school teacher uses 273.15, go ahead and do that. Okay, it's going to be 823 Kelvins. So I have that temperature ready. And then, oh, it's nice. Pressure is ATM, so 250 ATM that I'm going to use. And then kg, I don't like kg, so we need to change it to, let's start with that. So 10 kg, okay? 10 kg of nitrogen gas. We don't need that. We need grams. So in 1 kg, there's 1000 grams, okay? And 2. Why are we doing this? We need the number of moles. Remember, these are gas problems, so we're using the PV equals nRT, the ideal gas law here. Okay, so P is given, volume is what we're looking for. This is what we're looking for, and then we gotta get N. Okay, that's why we're doing what we're doing right now, and then R is a gas constant, so T is given. Okay, so let's all we need is get the number of moles. Okay, for whatever we're doing right now. Number of moles for nitrogen in this case. Okay, so we go multiply by, so kg of nitrogen cancels. Uh, Grams of nitrogen to moles of nitrogen, so we need P table. Okay, so nitrogen right there is 14.0. I'm just gonna use 14.01. How about that? Okay, so 14.01, but then it's times 2 to put to here. That's going to be grams of nitrogen equates to 1 mole of N2. Now multiply by, we need to go to ammonia gas, right? That's our ultimate goal. So let me see, 1 mole, when you look at this stoichiometry here, the ratio is 1 mole of N2 is equal to 2 moles of ammonia, NH3. So this will give us the mole of ammonia. That's what their problem's asking us. We're going to get 713 point about 8 moles of NH3. So we have that right now. Let me put that aside. Let me erase this work. Okay, we don't need that anymore. So this is number of moles for ammonia. Okay, covered up the P table there. Okay, so let's use PV equals nRT. nRT, we're solving for volume of ammonia. So volume will equal to nRT over pressure here. So N is number of moles for ammonia, which is 713.8 moles. Let me write all the units here. R is, I'm just going to use 0.0821. The unit for that is L, liter times ATM, over K should be on the bottom, mole should be on the bottom. So that's what gas constant is. Then temperature here, we found it already. It's 823. Make sure you change everything to kelvins, because you see right there, units must cancel. Moles must cancel like that. Then on the bottom one, it's pressure, which is 250 ATM. See, that cancels so fast, so we're left with liters, which is the volume unit there. So volume of the ammonia gas will be 192.92 blah 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 blah. But when you look at the original problem, that's 1 sig fig, this is 2 sig fig, this is 2 sig fig. Let's change into 1 sig fig, which will be 200 liters of ammonia, NH3. So that should be the answer.